Yesterday we talked about graphing systems of equations, right? Solving systems of equations by graphing. What did we figure out when we solved it by graphing? Where was the solution? Yes, the point of intersection. Okay? Is it possible for there not to be a solution?
Yes.
How? Parallel lines. And is it possible for there to be many solutions? How? They're on top of each other, right? They're coinciding lines. Okay? So, not all systems lend themselves easily to graphing. For example, this one that you see. X minus y equals negative 11, and 7x plus 4y equals negative 22. Yeah, the first one we could subtract x from both sides and divide everything by negative 1, and that's nice, easy, y equals something, right? But the second equation here, we'd have to subtract 7x from both sides and then divide everything by 4. That would be 7 over 4 is my slope and 22 over 4 for my y-intercept. Ick. Okay? So sometimes there's a better way to do this. So I'm going to show you this first example here. And I'm going to just walk you through the steps. Okay? The first step that we have to do is we have to decide which variable to solve for. Normally when we're solving by graphing, we solve for y, and then we put it in a calculator or we graph it on a piece of graph paper, right? In substitution, it does not matter what variable you solve for. However, some variables make it easier than others. Okay? If you're looking at this problem right here, which one of these 4 variables do you think would be the easiest to solve for? The first x would be the easiest to solve for. Right here? Because all I'd have to do is add y to both sides, right? And then it's x by itself. I could solve for this negative y, but after I subtract x from both sides, then I have to divide everything by negative 1. It's less steps if I just try to solve for that